We define now the trigonometric functions for any real number. Now the real numbers we simply map onto the unit circle by taking an angle in standard position with a radian measure equal to the number. And we take the point on the unit circle. And we can define the trigonometric functions by the coordinates. Sine of an angle is just the y-coordinate. Cosine of an angle is the x-coordinate. Tangent of the angle is y over the x, as long as x is not 0, and so on. And these are really the same as the definitions of picking any point on the terminal side, but r is equal to 1 because we're on the unit circle. Now, the unit circle is essential to understanding the points on the unit circle is essential to evaluating trigonometric functions. So we're going to look at what is often just referred to as the unit circle in math, and that's not just the circle itself. It's actually a circle with a lot of different angles, special angles represented. Any serious student of mathematics needs to have this memorized. We use it for evaluating trigonometric functions of all kinds of different of angles, and it's just extremely useful to know. So we're going to go through and we're going to fill this in. There's lots of different information here. First of all, we need to know what angles have these terminal sides. Okay. Then we want to know those angle measures in both degrees and in radians. We also want to know these points. We want to know the coordinates of all these points, since our trigonometric functions are all defined in terms of the x and y coordinates of our points. So we're going to start by looking at our angles, and I'm going to go ahead and do the angles in degrees first. And I'm going to write the angles kind of here on the inside. I'm just going to draw for the first couple angles what I'm really doing here. So if I just have here a flat, if I don't actually rotate it at all, that's 0 degrees. And I'm going to go ahead and write that 0 degrees. But then if I start to actually rotate, okay, we've got a 30-degree angle. Now that 30-degree angle, typically we would write it right here, but then that'd become really ugly if we started like trying to shove all these angles in these little spaces. So I'm just going to continue kind of writing it here on the terminal side. So this is the terminal side for 30 degrees. Okay, so all I'm saying here is that this angle is 30 degrees. Okay, we also have a nice special angle of 45 degrees and a special angle of 60 degrees. And then, of course, if I go straight up from the horizontal, that's an angle in standard position of 90 degrees. Now, we can continue using the special 30, 60, 90, and the 45, 45, 90. We can go through and create all of these angles based on those special angles. So we are going to continue here. Okay, 90 plus another 30 is 120. So 120 degrees. And then keep going, and we get 135 degrees. That's a 90 plus a 45. Okay, and then a 90 plus a 60 is 150 degrees. Okay, of course we know that a half revolution is 180 degrees. Now from 180 degrees, we can again do the same thing, add 30, and we can get a 210 degree. And then take 180 plus 45, we get 225 degrees. 180 plus 60 is 240 degrees. Okay, and then 180 plus 90 is 270 degrees. Okay. And so we can continue this all the way around. We get here 300 degrees, 315 degrees, and 330 degrees. Of course, if you complete a full revolution, that would be 360 degrees. So those are the angle measures for each of these terminal sides that are drawn in degrees, but we also want them in radians. Now, as far as getting those radian measures, there's multiple ways of doing it. You can just take each of these degree measures and convert them to radian measure by multiplying by pi over 180 degrees. Or you can try to remember that this 30-degree angle is the same as pi over 6. A 45-degree angle is pi over 4, and a 60-degree angle is pi over 3. And then 90-degree angles is pi over 2. And you could do the same process we did here by adding those angles together to get new angles. So either way you want to do that, I'm just going to go ahead and write what these measurements are in radians. So I've got this first one is pi over 6, then we have pi over 4, and then pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And, oh, I should probably say 0 over here, huh? Okay, 0 radians. And then we have 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then, of course, a full revolution, which is 2 pi. So these are the radian measures for the angles. Now, again, I said that any serious student of mathematics needs to have this circle memorized. That includes all of these angles in both radian and degrees. All right, and finally, we want all of these points. And the way I'm going to do that is I'm actually going to look at the two special triangles that we have. We have the 30, 60, 90 triangle, and so I'm going to go ahead and draw that here. Now the 30, 60, 90 triangle is, we can actually draw it in multiple ways. Now, drawing it in this way, opposite the 30-degree angle is 1. Generally we write 1 and then 2 for the hypotenuse and then square root of 3 for the other side. Now we can see, however, that the hypotenuse is going to be the radius of this circle, and for the unit circle, that's a radius of 1. So I actually have to divide each of these sides by 2 in order to get that 1 for the radius. Okay, I'm going to go ahead and just get rid of that and write that as 1. Now, each of these, the angles that have a 30 or 60 degree, okay, that's going to be this one, and this one, and this one, this one, okay, all the way around. So these have a 30 or 60 degree angle, reference angle, I should say, okay. Those are the angles that form a 30 or 60 degree angle with the horizontal axis. And that means that for each of those, we could just kind of place this triangle in the unit circle to fit. Now I'm going to go ahead and do that. It's going to look really not beautiful, but I'm going to go ahead and take this first one and place it right here. Okay, and if you place it right here, we can see we'd have a 30-degree angle here and a 60-degree angle here, and our 90-degree angle. Okay, just take that and transplant it right there. Now, this triangle, the x-coordinate of the point is simply the length of this side of the triangle, and the y-coordinate is the length of this side of the triangle. So I know the x and y coordinates of this point are just these lengths right here. So I'm going to go ahead and now write that. And I don't want it too cluttered, so I get rid of that triangle. So I've got this point here. The x-coordinate was this square root of 3 over 2. And the y-coordinate was 1 over 2. Okay. And I can actually I can place this triangle on at each of these places to kind of fit in the proper way. If I were to continue in that manner, okay, you can see that from this right here, I could connect straight down. Okay, all straight down to the horizontal axis, and you'd see that that would create, okay, again a 30, 60, 90. Now the 60 is down here and the 30 is up here. So opposite the 30 would be the 1/2 length, and then this side here would be the square root of 3 over 2 length. And that gives us this point here. That would be 1/2 square root of 3 over 2. And you can see that just flipped those coordinates there, which makes sense, right? And so we can continue in this manner all the way around the circle. Now what's really nice is we actually have already, we've done everything we need to, because the rest of these, the reference angles are either 30 or 60, and we already know how that affects the x and y coordinates. We just need to determine the sign of each of them, meaning that whether it's positive or negative. So for example, right here, this point, right here, okay, if I were to connect that down, it would look the same as over here. That has a reference angle of 60 degrees. So the x and y coordinates are actually going to be have the same numbers as I have here, but I might have some positives or negatives, right? So I just write those numbers and then decide what's negative, what's positive. Well, over here, I can see that the x coordinate is negative. So that's going to be a negative 1/2. The y coordinate is positive. Same thing over here, this point right here, that's just like this point over here. And I can see that again, the x coordinate needs to be negative because I'm over to the left in the second quadrant. It's going to be a negative square root of 3 over 2, and then a positive 1/2. Okay. And so we can go all the way around and construct these points based on that. So over here I can see, then you can start just comparing with points. This point has the same x coordinate as this one. Okay, negative root 3 over 2. The y coordinate is just flipped down, so that's a negative 1/2. Okay, this point right here, we can do the same thing. Take this point and flip that down. We have negative 1/2. Negative square root 3 over 2. Okay, this point right here is kind of like this point, but flipped down. That's 1/2, and then negative root 3 over 2, because the y coordinate is going to be negative down here. And then this point here, we can take this point and flip that down. We have the same x coordinate, and the y coordinate flips to negative. Now that was all with the 30, 60, 90 special triangle. But we also have a 45, 45, 90 triangle. So that is this triangle here. And we know that in a 45, 45, 90 triangle, we typically write it with 1s on these sides and a square root of 2 on this side. But we know that this corresponds to the radius of the circle, which needs to have length 1. So just like up here where we divided by that length, we have to take each of these sides and divide by the square root of 2. Now typically we would like rationalized denominators. So this, of course, is 1 already, so I can just write that as 1. But here, 1 over root 2, to rationalize that denominator, I can multiply by root 2 over root 2. So my numerator is root 2, and my denominator is, well, square root of 2 times the square root of 2 is just 2. So that's going to be the length of both of these sides. Let me go ahead and write that in here so that we can see it nice and clean. Root 2 over 2. Same thing here. We'll just move that over. Root 2 over 2. All right. And we see that we could do the exact same thing. If I were to take this, and let me go ahead and actually just do it. Place that right there, right? And it's not quite the right size. Okay. We can see, put it right there, and we see that this point, the x coordinate, okay, the horizontal distance would be square root of 2 over 2. and the y coordinate would be square root of 2 over 2. So that is this point right here. And so we have square root 2 over 2, comma, square root 2 over 2. And each of these points that have a reference angle of 45 degrees will have those same numbers, but again, some will be negative, some will be positive. So this point here has a negative x coordinate and positive y. And this point here, both x and y should be negative. And this point over here, the x is positive, but the y is negative. So we get all these different points from the 45, 45, 90 triangle. Finally, we're missing 4 points. We're missing these axis points. And those are nice and easy to get because we know that we have a circle of radius 1. And so right here, I just moved to the right one and not up any. That's 1, 0. And up here, I didn't move horizontally, but I moved up 1. And over here, I moved to the left 1 and not up. And here, I moved down 1, but not over. And that is my unit circle. Now, this process of finding all of those points can seem kind of daunting, but you don't really have to go through that whole process. It's important to understand where it comes from, but it's not important to do that process over and over again. What's important is knowing these points, and if you just look here, you can start to find lots of really cool patterns. Like everything is divided by 2, okay, except for these 4 axis points. And our numerators are, you can think of all of them as just a square root of 1, 2, or 3. Okay, the square root of 1 is 1, 2, 3, 1, 2, 3, okay? And that's all of our numerators. And, of course, negatives are easy to see based on location, right? Over here, our x-coordinates that need to be negative, but y-coordinates positive. And down here, both our x and y coordinates need to be negative, and so on. So there's a lot of patterns that can make it pretty easy to memorize this with a little bit of time.